Hello everyone, welcome to CodersArts. So today in this video, we are going to talk about data structures and algorithms. In this video, basically, this is the second part of the data structures and algorithms video, where I'll be explaining you about the linear data structures we discussed, that is stacks, linked list, and queues, by demonstrating you the code for each of them, stack, linked list, and queue, so that you would get an understanding of how programmatically we can represent data structures as such. And also, I would also be explaining you in this video theoretically about the concept of trees, which is non-linear data structure, right? As we have seen in our previous video that what are the non-linear data structures, in this video, I'm going to explain you what are trees, the types of trees, binary search tree, giving you the pictorial representation so that it would be easier for you to understand with the help of some examples, so that you can I would help you understand what is binary search tree, what is the concept behind binary search tree, and what is it based on. Along with that, I would also be explaining you the graph theory, which is some different types of graphs which exist in data structures and algorithms, and will be also demonstrating you with the help of examples. So let's get started. By the way, you can, for the practice purpose along this video, you can make use of any online compiler. For demonstration purposes, I'm making use of online GDB, which is online Java compiler, but you can also use any compiler. You can also log into LeetCode or HackerRank or any of the competitive programming platforms and side by side practice the logic. Okay, so let's begin. So first, I would like to explain you to what we have discussed so far. We have seen the different data structures, right? We have seen what are linear data structures. Though these are the data structures which follow a sequential format. Basically, all the elements in the linear data structures are successive elements because they are sequential arrangement is followed. So there are certain frequent situations in computer science when one wants to restrict insertion and deletion so that they can take place only at the beginning or at the end, not in the middle, right? So this is the way why stacks and queues come handy. Along with the explanation, I would also like to give you the hands-on demonstration. But firstly, I would like to give you a gist about what is stack, what is queue and linked list, and which order they follow for insertion, deletion, and what is the kind of order they follow. So that basically it becomes easier for you to code while I'll be hands-on demonstrating the code to you. So basically, stack is a list of elements in which an element may be inserted or deleted only at one end, called top of the stack. So basically, in a stack, as you can see, this is a stack, right? In the stack, you have the top of the stack and the end of the stack. So the top of the stack is called the first element, which, right, that is the top of the stack. So it is basically on top of one. All the elements are arranged such a way that they are on top of another. And stacks, you can perform two operations. You know, any data structure, it follows insertion and the deletion operation. So insertion operation in a stack, in simple words, is called as the push operation, whereas the deletion operation on the stack, like, deleting or removing the element from the stack, is called as a pop operation. Then it follows this format. This you have to understand, that whenever you are coding, stack data structure. Now, applications where stacks are used is there are numerous number of applications. So some of the applications where they are used is basically while arranging parentheses. That is one example. Or while you're arranging characters. Another example of where stacks can be used is where, for example, you have to follow the in the question itself, especially when you are logged into LeetCode, you see many kinds of questions where there are examples like character arrangement. The different characters are stacked together, and you have to also balance parentheses. You have also, there are examples like to calculate the minimum stack. So whenever in the question it is mentioned clearly that you have to follow the elements arrangement is in the last and the first out, and there is a push and a pop operation already, that is where stack comes into picture. Whereas in queue, the same concept of push and pop is referred to as NQ and DQ respectively. So in stack, last and first out, as in the last element which you are inserting in the stack, the last element will be popped out first or will be removed first. So whenever, take the example of a badminton the shuttlecock. So shuttlecock, or box of shuttlecocks, the top one will be removed first, right? So over here also, in the stack of coins, you can see, or stack of plates, the plate which is which is at the last, which is inserted at the last, put at the last, that will be removed first. You cannot remove the last plate. If you remove this last plate, all the other plates will fall, right? Or you cannot remove a plate in the between as well, because it will disrupt the arrangement of the stack. So it follows the last in the first out principle. That is what you have to keep in mind. As you can see, diagrammatic representation is given here, where you have the initial representation of the stack, then you have the top of the stack. Over here, A is the only element, so it is the top of the stack. This is referred to as the top of the stack when you have two elements, A and B. In the second example, B is referred to as the top of the stack. Now you can only keep on pushing elements till the stack until it reaches the size of the stack. Now you have to understand these all linear data structures like array, list, linked list, stacks, and queues. They are of a fixed size, right? They are of fixed size n. So when you see that it reaches a particular n value, top reaches a particular n value, that is when you have to stop your insertion operation, because that is an overflow condition, and you cannot stack overflow condition, because you cannot keep inserting more and more until it reaches a specific size. Also, when it is initially 0, you cannot remove anything because it's an underflow condition, because there is nothing in the stack. -1. Top is -1 in the first case, right? And top is equal to n. That is the size of the stack in the last case. So this is the diagrammatic representation, and this is basically, we'll be seeing practically how stacks can be, how arrays can also be represented as stacks. Top equal to 0, which indicates the stack is empty. Then push operation. This is the algorithm for push operation. We'll be coding it hands-on to understand how push operation can be used for performing the stack operations. So as you can see here, the push operation, this is basically to perform the steps to push an item from into the stack. We'll also, now whenever you're pushing an operation, whenever you're pushing a item onto the stack, the top value will keep on incrementing, because that you always, you have to set the counter as top, and top value keeps on increasing, and this element which is present, that is a stack element at the top index, onto that you have to assign this new item of yours, because you're inserting your item into the new top position. This is just the algorithm. We'll be seeing exactly how it is done while you're hands-on practicing stack example. So let's get started with hands-on practice of how stack is implemented. As I told, stack follows the last in the first out order. So you have to understand the methods of the stack. As I told, the push operation is where to understand the method. Push means element, pushing an element onto the top of the stack, whereas pop means removing an element from the top of the stack. Peek, there is another operation called peek, which I would like to explain to you. Peek operation, that is P-E-E-K, that means the method looks at the top element of the stack without removing it. So there is no deletion. There is a deletion, but only on the last element of the stack. So along with the popping operation, there is no removal of the, basically the difference between peek and pop, that is pop operation will remove the top element from the stack, but whereas peek operation, or that basically called the top operation, that will just return the last element of the stack, the top element of the stack. That will not remove, but just return the top element of the stack. That is, these are some of the methods. And to understand, Boolean method is also there, called as empty, to check if a stack is empty or not. Now, before we get started, this is how you have to import in Java. You're basically importing all the libraries. So import Java. I'm going to explain you this stack implementation in Java, by the way, but the logic is same. The logic of push pop is same in all the programming languages, but I'm going to explain this concept, the coding, in Java. Okay, so we are going to create this public class main over here. Then inside public class main, we all have a main method, right? Any method will have a main method. So I will just explain you. First, we are going to create an instance of the stack class. So we have, there is a stack class in Java, and stack class in Java, which is an instance of the collections framework in Java. Okay, so linked list and array list, stack, queue, they are all part of the collections framework in Java. So this is how you exactly create a stack. Stack integer, let's name it as stk. For now, stack integer stk is equal to new stack. Now you can see here, stack integer stk, new stack. This is how you are going to create or initialize this. Basically, not initializing now, but you're just creating an empty stack. right? You're creating an empty stack and you're of the integer type here. So stack can have character type also. Like I was saying, in some applications like character arrangement or parenthesis, special characters arrangement. Over there, balancing parenthesis is one application of stacks problem. It's a very common stack problem you'll encounter, that is called as balancing parenthesis. So over there, we require the data type of the stack to be character. Here we are putting the data type as integer. So stack integer, stack is equal to new stack. Then checking stack is empty or not. Now the exact name of the method which I was explaining to you, that whether to check if the stack is empty or not, the name of the method is empty. So simply just write empty, boolean result empty. This will let us know whether this stack stk which we have created is empty or not. If it is empty, it will return a true value because boolean, the return type of boolean is true as we know. And if it is not empty, if it contains at least one element, it will return a false. And it will be stored. The answer of this stack.empty will be stored in this result variable. Now, after we have checked if the stack is empty or not, now let us keep pushing elements onto the stack one by one. Now, I told you how do we push elements into the stack? By simply making use of the push operation, right? Now, these push and pop, they can be inbuilt elements as well right? So basically, the methods like these push operation, pop operation, you can either create them, that is user defined methods, or they are already a part of the method. They're already a part of the stack class. So their characteristics basically. So because of that, you can directly import them over here. Since you're importing the stack class and created them, you can make use of push and pop as it is. Let us see how can we push elements onto the stack one by one. So let's say you're pushing into this empty stack. You're pushing, we can put it in any order, need not be 1, 2, 3, 4. So let us just put it randomly. You have pushed the first element onto the stack. Now let's see this second element onto the stack. Now similarly, you can keep pushing the another element into the stack. Let's give a bigger number, 120 maybe. Yeah. So you're just pushing 4 elements onto the stack. So the length of the stack over here is 4. Now let us print the elements of the stack. Now to print these elements of the stack, you can make use of the print statement either, right? So instead of doing that, you can just write elements of stack are so and so and just print the stack. You can do that as well. So you're making use of the print statement. In Java, you print the statements like this: system.out.println. So elements of the stack. As we want to check the elements present in the stack, we are going to print it this way. So just write the variable here stk, and all the elements of the stack will be printed. Now, how do you think the elements will be printed? Will it be 3, 5, 2, 120, or will it be the other way? Any guesses? So it would be in the same order as insertion, because I said stack is last in, first out, right? So whatever is the last element which is pushed, which is 120, that will be removed first. But then when you're printing it, you're traversing it right in the order in which they are inserted. This is one important point you have to note, because many people get confused. Like while you're printing the elements already pushed into the stack, they will be in the same order or in the last in, first out. But last in, first out means whenever you want to perform the pop operation. Suppose if I say stk.pop, then simply doing the pop operation will remove 120. It will not remove 3 because 3 was first inserted. But the last inserted element was 120. So last in, first out. That is, the last element which was inserted, 120, gets popped out or gets removed from the stack of elements first. So I hope this has made sense. And then let's now store all this answer. As I told, whether stack is empty or not, let's just put in this variable result is equal to stk.empty. Now let's check if the stack is empty or not. This question we can print it as well. So if you want to check this, the result over here, you can print it if the stack is empty or not. So let's give it a question like, is the stack empty or not? So if the stack is empty, it will return a true. If the stack is not empty, it will return a false. And because the result variable is storing the result, that is going to check, because empty is the method we are using here to check whether the stack is empty or not. Now it's enclosed in the parenthesis. Now let us check by running this code whether we are going to get this particular, we are going to get the output. Now, what is shown and what will be shown in the output? It will be shown these two print statements. Basically, you're going to get firstly, is the stack empty or not? You're going to get that. And you're going to get also the elements present in the stack. The elements present in the stack one by one in the order of their insertion. Let us check. On compiling the program. So as you can see here, the result which we get here is elements of the stack are 3, 5, 2, 120. As I told, the order of insertion of the elements is the same, right? So in the order in which you are inserting or pushing the elements into the stack, in that order only the elements will be printed. So 3, 5, 2, 120 are the elements of the stack, and checking if the stack is empty or not, it is returning a false, because stack.empty will check if the stack is empty or not. Initially, yes, the stack is empty. That's why we are basically just created a stack, empty stack here. But then over here, when I just, before, after here only a print statement, like I just print the result here, then what do you think? It will be a false value because nothing was inserted in the stack. So yes, stack is empty. So it will return a true value because the stack is empty. Stack.empty will return true up in this statement. But when you are already pushing these four elements into the stack in this order, then checking whether the stack is empty or not, it will return a false value. I hope I have made this concept of empty function clear to you, which is an inbuilt method of stack class in Java. So now that you have understood what the empty method does, let us now understand example of push and pop example in Java. Okay, how to like push elements in Java and how to pop elements in Java. So I have not explained you pop over here, but then I have just given you a rough idea on how exactly the push operation is done. In detail, we are going to check how the push and the pop operations will be done in Java. For example, just for the demo case, I can I can just perform the pop operation here as well, like then using this inbuilt function pop. stk.pop, let's say just do stk.pop without even specifying the element. Now let's check whether it's going to remove any element or not. So it has removed the last element. As I told, last in first out is the stack. So you have to make sure, you have to understand this, that LIFO is the principle with stack follows last in first out, whereas Q on the other hand follows first in first out, which is termed as FIFO. So LIFO for stack and FIFO for Q. This is the concept. I hope I have made this concept clear. And while you're performing this pop operation, 3, 5, 2 because 120 is removed. Now, what do you think? If I again do a pop operation, what will be the answer? Again, doing the pop operation will remove the last element. Now we just have 3, 5, 2 as the elements present in the stack. So if you do again a pop operation, it will remove the last element, which is 2, and just give us 3, 5. Let us check. Yes, as you can see, the elements of the stack are 3, 5. It is just removing the element. Now, what if you say, if you specify explicitly, like stack.pop of, let's say you want to remove 3. Can it be done? Let us check if this can be done or not. It is not, because pop operation will always remove the last element. Even if you specify like this, it will not happen. So whenever you want to, what if you want to remove an element present somewhere in between the stack or like that? Do you think it is possible? No, because stack follows, it's a sequential data structure, right? Linear data structure. So in that case, you have it always the default for the arrangement of the stack is last in first out principle, which it follows. So whichever element is inserted at the end, that will be removed first. So as you can see here, the error says method pop in class stack cannot be applied to the given types. Why? Because it is required no arguments. So pop does not require any arguments, but we are passing in some, we are specifying the 3 should be removed. That is not possible in Java. So it says that we are passing an element, it says found int, that is the integer data type 3 is passed in, although it is not expecting anything for us to pass. So now that you have understood how this pop operation is working, let's see what peak operation does. I was explaining you this, right? Peak operation. Now peak operation is nothing but called as the top operation as well. Peak and the top. Peak and top methods are the same. They will not remove any of the element, but just return the last element of the stack. Now let us check what will be the output of this. Firstly, the 120 will be removed. See, as I told, 120 is removed. 3, 5, 2. Do you see that any change in this by doing this peak operation? Has it removed 2? Like if I in place of peak I have put pop, then it has removed 2 as well, right? Because pop was removing the last element. But peak on the other hand is not removing the last element. It will just return the last element. How do you return the stack.peak now? Let us print it to see how what is the output of this stack.peak, and the output of stack.peak should be the last element, which is 2. Let us check. So as you see here, 2 is present here. 2 is the element. This is the first print statement. As you can see, the first print statement is returning 2. Why is it returning 2? Because after performing the pop operation, you just have 3, 5, 2 in your stack. And in 3, 5, 2, which is the last element. 2 is the last element. So that is nothing but pop operation, which will return you the last element. So I'm writing a commented statement for you to understand. Firstly, you have to understand the LIFO is the stack operation. Stack follows LIFO principle. Stack's principle is LIFO. Please make a note of all these concepts because they can come very handy for you to understand, apply in your programming, and also to answer answer verbally in your interviews. So when I say stack.pop, pop will remove. It will remove or delete, and it will remove the last element basically, right? Last element of the stack will be removed. What about this peak operation on the other hand? When I'm printing it, the top or the peak operation, it will just return. It is not going to remove it. As you can see, elements of the stack are still 352. Although 2 is returned as the output of this peak statement, it is not going to return, it is not going to remove any element present in the stack. So the stack elements will remain intact, that is as it is. So top's method will just return the top of the stack, that is return the last element of the stack. So as you can see here, the last element of the stack will be removed. Now after doing this, what is this empty method doing? Empty method will check if stack empty or not. These are some of the doc strings I'm writing for your reference. You can make a note of this small program to understand the difference between all these things, small concepts, that is empty, the difference between pop and peak, what is the push operation doing, which is inserting, in what order is it inserting, and how is the output of this. I hope this is clear to you. Now let's get into the push and the pop example in Java in a detailed way. Now that you have understood how the push and the pop is working, let me clear this. Firstly, this is the stack is declared in this way. Then you want to push the elements into the stack one by one. Now let us just check how exactly that could be done. For doing that, let's say I'm making use of the push operation, but I said also you can make a user defined method, right? You need not use this already existing method push and pop and like stacks. You can make your own user defined method. Now with the help of user defined method, let's see how push element can work. So push element, let us just say a method is push element, right? Push element is a method. Now let's see, this is a user defined method push element. Let me, after doing this, push element, so all the elements will be pushed one by one into the stack. Now let us perform pop element. Pop element is another user defined method. Now pop element will take the argument as stack, because generally you were seeing that pop does not require any argument, but when you're performing you're making use of a user defined method. These are user defined methods. See, push element, pop element, we can name it anything because we are the ones who are creating this kind of functions or methods. So we are naming this as push element and pop element. Then pop element with the argument as stack, and let us perform, for example, another pop operation, pop element of stack. Once this is done, let us put, for example, our logic to check whether the stack is empty or not. Let us put that in try statement. You must be aware of this, right? It is a basic programming concept, try catch statement. So that is basically you're putting your logic over here inside the try, and in the catch you will write what kind of exception will be caught. Okay, so let's say pop lm of stack. Pop lm of stack is the logic. So you're just pushing it into the try. That is, it throws the exception of stack is empty. And let's say if you to always a try will be followed by a catch. Try will not exist without any catch. It should have a catch statement. There is another like finally is also used in Java. Try catch finally. So for now we are making use of this try catch. Let's say empty stack exception is the exception to be caught by this catch statement, because we are going to check whether the exception will be thrown if the stack is empty or not. So let's name the exception as E here. Now, after doing this try catch statement, then we will let us say we are going to print. Okay, the catch should be enclosed in the yes, the catch will be enclosed in the braces as well. So when you want to check if the stack is empty or not, let's put that also in this catch statement. So that will be system.println empty stack. So as you can see here, if the exception is caught, then it will throw the exception if the stack is empty, and it will also in the catch statement will print the stack is empty, or just say empty stack. Now once that is done, let us come out of this catch statement, come out of this public static void main as well, and because this is the main method. Now once we have this just main method, as you can see, push lm is one method, pop lm is also one method. So definitely we have to create these methods, the definition of the body of these methods, right? So let us create those methods, push element, pop element. So static void push element, this is the user defined method we are creating. Stack stk, because that is the one of the arguments we have to pass. Another arguments we have to pass is int x. Int x is nothing but the element or the value you want to push it to. As you can see here, push element was just taking one argument, but while defining the function, you have to also pass in a parameter as stack, because it is into the stack that you're pushing the element. See, it says stack stk dot push element of 3. So you're pushing these values x, 3, 5, 120. These are nothing but x here. Okay, we are denoting by these are nothing but the formal and the formal arguments, basically we say in Java. So for formal and actual arguments, which we call. So we are passing this parameter name as x. So these can be taken any values. So all these have to be pushed into the stack stk. So static void push lm stack stk index. So once this is done, then we have to invoke the push method. Now how do we invoke the push method? We make use of this stk.push of new integer of x. This is how we are pushing the element x into the stack. And why we are making use of this new integer is that because we are pushing a new, it is of the integer type basically, right? You're pushing an object into the stack, a value into the stack of the integer data type. That is why you can write here new integer of x. Once that is done, if you want to just check, if you want to see the modified stack, or you want to, after invoking the push method, or also check the value of the element you have pushed, then you can print the print methods and statements. They come very handy while you are debugging. So whenever you are debugging, it's always recommended for you to keep checking whether the output you're getting is correct at each step or not. So let's say plus x is the value. If you want to check if what element you have pushed, what is the push operation actually pushed the element, you can write x over here. Now if you want to print the modified stack, finally the stack, okay, you have, why is it modified, is because you have inserted something, right? You have pushed elements into it. To check that, you can write stack values, or just say stack over here, and then you can print the stack. This will print the elements of the stack. Once this is done, let us come to the pop element code, because the push method is done. Now let's make the pop method. I'm just copy pasting this code over here, and then we can modify. So this is for the push. The definition can be changed to pop lm, as you can see here. Then it has this argument, that is stack stk. It will not take any other argument, because the pop element will just pop the element, the last element of the stack. As we have already seen, if we try to give any value to it, saying that we want to pop or remove a particular element only, that cannot be done in stacks. You have to understand that that cannot be done in stacks, because stacks follow the last in first out principle. So when you are popping element, you have to remove this int index. So sorry, I have removed it for the push. You have to remove it for the pop. Push will take two arguments. It is a stack and the value because you're pushing this value into the stack. With stack, you do not have to say which element of the stack you want to remove. You just have to specify the stack name. So that is given as the argument here. Once that is done, you have to change something, right? How can you change that? You can let us change this. Suppose you want to, firstly, you can just say system dot, you can just print over here as well. Suppose system dot out dot println pop, because you're performing the pop operation here. So let's say this is starting of your pop operation. So since you're starting of the pop operation, it's over here. Then invoking the pop method. Pop method, that is POP. I'm saying pop method in Java. For doing that, let us assign it to a variable first. So for example, let's store the popped element into this variable first. The element which is going to be popped, and typecast it to integer value. Why are we typecasting? Is because the pop element may or may not be of the integer type. So we have to also see every stack is it's a part of the collections framework in Java, right? And each of them is considered an object. So whichever value you are inserting, that is an object. So you have to typecast. You have to basically convert the data type, the object, to integer. That is why you're doing integer here, specifying it as integer stack dot pop. Then after you are popped, invoke the pop method and the element has been popped from the stack, you can print what element has been popped or deleted from the stack. But when you're using the peek method, you need not do the print statement, because all instead of deleting, it will just return by itself. The peek method, as we have seen in the previous demo, we have seen that the peek method or the top method will just return the last element of the stack. But when you're doing pop, it will delete the element of the stack. So some place or some memory location is needed for you to check which element has been deleted from the stack, right? So that is why we are making use of this X value here, where we are deleting the element from the stack. So system.println of X. Now to print the modified stack, let's say we can just print the modified stack, which is system.out.println stack plus stk. So this will finally give us the modified stack, as we have this printed in the push element also, that after pushing the elements into the stack, we have also printed the stack. Over here as well, we are going to check after popping the elements of the stack, we are going to also check whether the elements have been popped or not. By the way, in the push element, you have performed the push operation, and also you have to, here you have, after pushing the basically before this push statement over here, since you're making the push, you have to also specify here that the stack dot push method here, because you're pushing the elements one by one into the stack. So over here as well, how you have specified here in the pop method, in the push element method also, you have to specify new integer of X. This is how you're going to push the elements. By invoking the push method, you're pushing elements into the stack. After that is done, you're going to print the modified stack, and then check all the elements of the stack. Then similarly for the pop operation here, then this is closed, the braces, and we have also closed the main class. Now let us print. Let us check by running this code what will be the output. We got some errors and it says okay. So we have it in the 23rd line. Yes. So there is I have not included that in the double quotes in the 23rd itself. Yes. Seventh line. So it says stk.pushlm of 3 cannot find symbol. Now see, debugging, you have to understand why these errors occur as well. There will be many errors, right? You have to understand why they occur. So here it says method pushlm int variable stk of type stack cannot find symbol, method pushlm int, and the name is pushlm here also. Pushlm here as well, and there is push element here as well. So Okay, so I have used stack dot, okay, this is the inbuilt method I've used. stk dot push, which I'm pushing it here. Then it says push lm, push lm stack. Okay, so as you can see here, this push is, see, as I was explaining you, in stack there are in the inbuilt methods and the user defined methods. The user defined method over here is push lm, and how you have defined it over here is it is also taking stack as one of the arguments. But whereas the inbuilt method push was taking, now you have to understand push will only take the element, that is only one argument, which is nothing but the element you want to insert. But the your user defined method, according to the definition we have created, you have to also provide stk here. So always align it according to your definition. Pop also we have defined it because it's just taking your one argument. Now let us check now. So according to the, basically the formal and the actual arguments should not differ in length. It says method push element variable stk of type stack. So as you can see here, a symbol is method push lm stack stk dot push lm, and a method push lm stack integer. It's over here stack stk we have provided, and stk stk dot push lm method push lm is not found, but then we have push, we have created the method here, right? Okay, so one important thing you have to understand is while you are also pushing elements, it should, you're not invoking it over here because you've already defined, you already provided the argument as STK. So you have, but if you were using the push method, then you need not provide, then you have to provide stk.push as you have done here, stk, because this is a inbuilt method. So see, this is how debugging helps you. It helps you to resolve errors. And how is the debugging done? It is done by making use of the print statements. So stk.push, you can make a note here. I'm writing in the doc string. It is for the inbuilt function of stack. So push, only push is a inbuilt function. Push is a inbuilt function or already a predefined function in Java. But as you can see here, push lm is the name. It is we are creating. And according to the definition, you need not do stk.push lm directly by passing stk or the stack name in as the parameter into the push lm. It will work. Yes. As expected, you can see this is the output, right? So you have to be very careful between the push operation, the push method and the push element method. Push element method is the one we have created. So you have to align it with the definition and need not invoke it by stk.push element. But when you're using push method, then you have to write stk.push over here like this. But while making use of the push element, you have to provide stk or the stack as well as its value as two parameters to the function. So as you can see the output, we are pushing 3. Then after pushing 3 into the stack, we have 3. Then push 5 into the stack, we have 3, 5. Why don't we have 5, 3? We have 3, 5 because as explained in the previous demo as well, it is going to print in the order. So it is going to push the elements in the order you're pushing, one by one. So 2, 3, 5, 2, 120. This is all the elements we have in the stack. After performing the pop operation, it is going to delete the last element. We have 120. Then again perform pop operation. And then we are storing this pop as you have observed in this particular code of ours. In this pop element, we are storing the element which is popped or removed into a variable x and then printing that x variable and finally the stack. So as you can see here, when we have popped the element from this particular stack, we have popped 120. This is after performing the pop operation. Then again performing the pop operation, we will see that these are the elements in the stack. Again, performing the pop operation, we see that after 122 will be removed. And that 2 is stored in x variable. So that value of the x variable is 2 here. And then printing all the elements present in the modified stack, which is 3, 5, because 2 and 120 have been removed. So now we have 3, 5. Again, perform the pop operation, remove that, it will remove the last element 5. And then in the stack, we only have one element, which is 3. I hope I have made this clear by making use of how you also create your user-defined functions by naming them anything, push element, and also can accordingly change your arguments. Right, you can accordingly change your arguments or your formal parameters. So you can also create your user-defined methods to understand the push for the insert and pop for the delete operations in Java in stacks. So once that you have understood how this is done, let us now understand how the peak method works, which is the last method we are going to discuss over here. Basically, our agenda was to understand how insertion deletion operations is done. And when I was talking about the peak method, peak will not delete anything, rather it will just return you the last, right, return you the last element. So now let's check not with integers, but with some other example. So let me just clear this. Now that you have created this main method. Now let us say you want to create a stack of strings. Instead of creating a stack of only integers, we can also create it of a different data type. So let's say we have a stack of string. So stack string stk is equal to new stack. As you can see here, this is the stack element. This is the stack data structure. Then push elements into the stack one by one. So you can push the elements here, stk.push of apple. For example, let's push all the fruit names. That will be easier for us. That, let's say, any name, like you can also put ABC, anything, but it has to be in a string form, and string has to be enclosed in double quotes. See, now you are not writing push element. You have to write stk.push because this is an inbuilt method in Java. In the previous case, we were creating our own method. We create a user-defined method named push element. Over there, we need not do stk.push. But when you are using the inbuilt push element, push method in Java of the stack, then you have to invoke it. You have to invoke this method by making use of an object stk, which is an object of the stack class you have created. Then stk.push of any other fruit name like mango, and maybe just last element we can push. Once you have pushed all the elements into the stack, you can print the elements into the stack, as we have seen. Print all the elements of the stack. So let's just say stack, and this is how you can print elements by just calling this by just putting this variable plus and then concatenating with stack plus stk. Stk is the stack which will store all your strings, all your elements, which are fruits in our case. So now what if you want to access each element from the top of the stack? So the top of the stack over here will be orange, right? You have inserted elements here: apple, grapes, mango, orange. Orange is your last element, which is the top element of the stack, right? So when you have to access each element of the stack from the top of the stack, you have to make use of something called as the peak method, because peak will return the last element of the stack, in our case orange. Let's just see with the example. So we have, since it's a string, we have to store the last element, which the peak will return, in the variable string variable, right? Had it been some integer stack, the stack of integer data type, then we can use int data type here to store the final output of the peak method. But then since the peak will return the string data type, we have to uh, place it as string here. In that is the parameter, the variable has to be of string data type. So string fruits is equal to stk.peak. Peak will be same as top. I can also change it to top and show it. So let's see what peak will do. System.out.println. Now finally we have to just print the element at the top. Same element present at the top of the stack, at the top. Let us see what element we'll get at the top of the stack. That will be stored in fruits, this variable fruits. So let us check that. Upon running this, you will see that orange will be printed. As expected, stack we have inserted, pushed all the operations into, all the elements into the stack, which is apple, grapes, mango, orange. Element at the top is orange. Now let us see what is this peak. Peak operation will return the last element. It is not going to delete. It is not going to delete the elements of the stack, but just return. So let's say top. What does the top method do? Okay, variable stk of type cannot find symbols. So method top over here will, okay, the top does not work in our case. Top, we can make it as a user defined method. So for example, peek is the built-in methods, like how we had made push element, pop element. We can create another method, user defined method with the name as top, and inside top method, we can write the peek method, and then making use of the peek inbuilt command, we can print the top element, which is orange in the stack. So if to understand what the inbuilt methods of stack, you can say push for the insertion, pop for the deletion or removal, and peek for returning the top element of the stack. I hope I have made the concept of stacks clear to you. And now let us understand the concept of queue, which follows the first in first out principle. So this is the concept of stack. Now, once the basic operations performed in stack have been understood to you, how exactly insertion is done, pushing operation, these are basically some of the algorithms for you to follow. But definitely it is recommended that to you that you perform hands-on practice of all these operations, so that while performing the real life problems and solving them, you can apply these concepts of stacks, queues, and leverage them to solve problems. Now let us understand what this is about, all about the applications of stack, basically, that where exactly stack is used. So I will be just explaining you firstly what is queue, then we'll be explaining you linked list, and then followed by binary search tree and graphs. Okay, so we have discussed arrays, linked list, stacks, queues. Okay, so I would like to explain you firstly queues as well. Queues follows the first in the first out principle. So let me give you an example while coding itself. It's similar to stack, but the difference is that there is first in first out principle. That is the element which is inserted first into the queue that will be removed first. Unlike the stack, that is one thing you have to understand. And queue, it's also a linear data structure which is which is used to store elements just like any other data structure. Okay, in any manner, but it follows the first in the first out principle. And basically, it is all queue is also like stack. Queue is an interface in the Java which belongs to java.util package. That's why we are importing java.util here, and it extends the collection interface. Like we have seen in stack, queue also extends the collection interface. So let us understand how insertion operation, deletion operation happen in queue. Insertion operation in a queue is called as enqueue operation. Deletion operation or removal of the elements present in the queue is called as a dequeue operation. Whereas there is another, there are different types of queues also. Like basically linked list is also in fact a queue. Okay, linked list, the classes which are used to implement functions of the queue are linked list as well. So array dequeue, priority queue is another concept that you'll be learning later. Priority queue and also linked list, which are basically different functionalities of the queue implementation. So once you have understood all this, then let us delve deeper into what exactly, what is the poll element. Another method you have to be aware of in queues is poll method, POLL, which is removing the head of the queue and returning it. Like we had the top or the peek method. The peek method in stack, we have the poll method in the queue, which removes the head of the queue and also will be returning the head of the queue. So we have top element in stack, the top of the element. In queue, we have the head of the element, right? So enqueue is for inserting an element in the queue. Dequeue is for deleting element in the queue. And you have something called, since queue is like you have both the sides. Okay, so when I talked about, when I say it has both the sides, unlike the stack, if you see here, I would like to explain you. Like, for example, this is a stack you have. So in a queue, that along with the upper end, the down end also is open. So you can basically, that is called where you have first in first out to be followed. So instead of last in last out, if you're doing first in first out, then A will be accessed here, because that is the first element which is inserted into the queue. And in the queue, you have both the ends open. So we have the head of the queue and the rear end of the queue. So head of the queue is in the start, and the rear end of the queue is the last, is called as the rear part of the queue. Head and the rear. So the method which returns the front of the queue, there is a built-in method in queue which is called front, and to display That is another method which traverses the queue and will also display the methods of the queue. Let us just see how practically all these methods can be done. So I would like to first explain you how we can create the queue. So in order to do that, let's say, okay, there is a public class main here. Then after you have this public class main, then what do you think firstly we have to do? First, we have to, in order to implement a queue, we have to first declare and initialize the queue, right? You have to first, like how we have created the empty stack, you have to create an empty queue. So let us say we have the private int. Okay, let's make it static for now. Private static int. You have front, that is a part of the queue, the front end. Then you have the rear, and let's say you have the size of the queue as the capacity. These are nothing but the variables we are only giving. Capacity is the size of the queue, store the size of the queue. So now let's say, in order to create the type of the queue, private static int array queue. We're making use of the array data structure here for simplifying it. I'm making use of the array data structure here. So private static int queue array. Once this is done, let's say now we have a built-in, let's say we create a method queue method of parameters having as int size. So after you do this, let us initialize front, which is the, like in we have seen in stacks case, we have something called top which has to be initialized initially to 0, top equal to 0. Similarly in queue, you, instead of top, you have front and the rear, right? You have front because you have both the sides open in queue, so you have front and the rear. So let us initialize both front and the rear to 0. So you can just say front equal to 0 comma rear equal to 0, or front equal to rear equal to 0. This is for your initialization. Capacity, which we have given as one of the arguments over here. Capacity, we can just say capacity equal to size. So this is something like a constructor, we can say we are creating of the queue class. So queue is the class and we have this constructor. We can, but queue class will come if we are putting it as public class queue. But since I'm making use in this online Java compiler, I'm giving it as main because it works with the main method. But you can definitely write queue when you're working in local compiler or in your program ID. Then you can write public class queue and give it as a queue name. So similarly, the constructor should be having the same name as the class. Constructor is nothing but a method or a function which has the same name of the class. So this is a constructor we are creating, which has the main constructor. The name of the constructor is main. It has the same name as the class, and it will initialize all the basically all the variables present. So it is going to initialize all the member variables of the class, the constructor. So we are seeing size. We are going to assign that to capacity here. Front and front, rear, capacity were the three variables we had created, right? Of the type private static int. Then we are going to initialize, because constructor's sole purpose is to initialize your variables of the class. So q equal to new int. This is how we are going to create. And that q is also not a dynamic data structure. Like stack and array, q is also not a dynamic data structure. But array list, on the other hand, is dynamic. That is, it keeps on, you can keep changing as the size as and when required. But queue is a fixed size. That's why initializing the queue and the size, you're creating it, and the size you have specified as capacity over here itself. Then once this is done, let's say you want to insert an element into the queue. So for inserting it, like in the stacks, we have seen push element was the push is the operation in the stacks to push element in the queue. Similarly, to insert an element into the queue or push element into the queue, you have a inserting an element into the queue. The method is queue. So let us just say enqueue is the method for now. So static void enqueue. For now, I'm just writing it as n. Okay, let's say enqueue is the name. Enqueue int item. Since you are appending or inserting this item as the element, the integer element into the queue, you have to specify the data type and then the variable. So int item. And first condition should be to check if the queue is full or not, right? As I've told in the stack also, you have to first check if the queue is full or not and data structure is full or not. If the data structure is full, it is the overflow condition. You cannot insert. The queue is full and you just have to simply break from the loop. But if it is not full, then there is a chance for you to keep on inserting. So that condition is very important for you. This is the edge case you have to keep in mind. So if capacity equal to rear. Rear is the last end of the queue. That is, you have reached the end of the queue or basically the size, the capacity of the queue has reached the rare. It is equaling the rare. Then you can say, you can just print system.out.println queue is full. So basically queue is full is nothing but it will just tell the user that you cannot insert any more elements into the queue, and just return statement simply without returning anything. It will just break or come out of the loop. So after this, an else statement, if the capacity has not reached there, or we can say there is a chance for us to still insert elements at the rare position because it is the queue is not full, then you can insert or you can perform the queue operation, NQ operation here. So the NQ or the insert operation you can perform here, as you have named your queue with the spelling. Just check all the spelling names as well. So at the always you have to understand that in NQ operation in a queue will happen at the rare end or happen at the rare of the queue. Whereas DQ or the removal and the deletion operation of the queue will happen at the front of the queue. You have two parts of the queue, right? Front of the queue, that is the front, rare, which is the last. Rare of the queue and front of the queue, capacity being the size of the queue. So whenever you are inserting elements into the queue, always insert at the rare position of the queue. The index should be rare. But when you are deleting elements of the queue or dequeuing the elements of the queue, then it is done at the front position. So this is how you are inserting your item, or inserting the item is nothing but the element, the new element you are inserting. Similarly, now you have to increment the pointer. Rare is your pointer. It's like a counter pointer, like you have ij, you keep on updating the counter. This is a rare. So you have to keep moving forward whenever you're inserting element. So that is why you're incrementing your rare pointer by doing rare plus plus. After doing this, come out of this else statement, write return here. Okay, so once this is done, you come out of this function. NQ function you have done. Now there should also be a DQ function, because once you have inserted all the elements into the queue, then naturally you should also be able to delete elements into the queue. Let us check how DQ operation can be done. So let's say there is an operation static void, and let's say there is a DQ operation. So static void DQ. If front equal to rare, that is basically there are no elements at all in the queue. That is, a queue is empty, because if front equal to rare, it means front equal to rare equal to 0. That is, this is only possible when both of them are 0. That is nothing but the queue is empty in the first place. So if this is the case, then you have to print similar to how you have told that you have told that queue is full. You have to also mention and print a statement here that queue is empty. So these are the edge cases. Please, you can make a note simultaneously to understand where queue can be empty, where queue can be full. These are something you have to keep in mind. But then after performing this operation, checking, then come out of the loop, then come out of this if statement. In the else condition, you have to mention, you have to now keep removing elements of the queue, or basically perform the DQ operation. And for doing that, you have to first keep on traversing the elements. For doing that, always the best criteria is to start with a loop. So let's say loop which starts from 0th position to our rare minus 1th position, because you're starting from 0, so it's rare minus 1. Till that point you have to keep on going, then keep on traversing. So that is done. So q at I, this is how you make a delete operation. Basically, q at I equal to q at I plus 1. So element which is present at the in the queue in the I plus 1th location, that will be inserted in the ith position. So once that is done, then you have to basically this is how inside the else statement you have done. But then what if you have to also set the queue to the rare the element which is present at the rare index of the queue, you have to set it to 0 if rare capacity is less, if rare is less than capacity. Okay, so if the value of the rare, the counter which is rare, the last position, if still it's less than capacity, then you have to set q at rare to 0. That is exactly what I'm saying. That is, if rare, this is the condition. If rare is less than capacity, then you have to write q at rare equal to 0. This means that the element which is present of the queue at the rare index is assigned to zeroth location, zeroth value. Then after doing this, you have to decrement the rare. And since you're performing the DQ operation, for the NQ operation, you have to increment the rare by doing rare plus plus. For the DQ operation, you do rare minus minus. Now come out of this else statement and simply put a return statement here. Okay, after putting this return statement, you can come out of this function, DQ function. Now that we have made the NQ function and the DQ function, the last function you have to make over here is basically the display function of the queue. Now, display function is nothing but to basically print all the elements of the queue, you can say, or to traverse from front to rear and print all the elements of the queue. So, in order to do that, you can print all the elements of the queue by making use of the display function. So let us do that. Static void display as the function name. Then int I. We are making use of this variable for our convenience. We can make a use of this variable. See, display method is nothing but printing. It's similar to print where we are displaying. You're traversing each element, traversing as I've told you in our previous video in the starting while explaining you all the terms and data structures. Traversing is you're accessing or processing each element one by one. So how can that be done? If front equal to rear, then you have to front equal to rear, then you have to write system dot out dot println queue is empty. Basically, this is the case where queue is empty, edge case, if front equal to rear. Then you can just return or you can add a return statement. Basically, then after you do this, then you can come out of the if condition and write a for condition here to traverse all the elements from the front to the rear. Front is the starting index, rear is the ending index of the queue. Okay, the starting end of the queue to the rear or the ending end of the queue. So now you say I is the counter, right? You're traversing all the elements one by one from the starting to the ending. So I should be initialized to front because that is the starting element of your queue. It will always be less than rear because since that you have to keep traversing till it is rear, till it reaches a rear end. But after that you should not traverse. So after this, system dot out dot println queue at I. Once that is done, queue at I, then you have to return. Once the return statement is done, then you come out of this display method and you can print the front of the queue. Basically, you can print the front of the queue. There is another function for that. You can add that function to print the front of the queue, or simply you can just create another class also with the main method, and just in that particular class you can write the main method and print all the elements of the queue. So let us do that. Let us just add the public static void main. So in this case, we don't have the public main class yet, right? So a main class is very important for us to call all these functions, all these individual functions which we have created. That is the display function to traverse element at the end, then the NQ function, DQ function, and then also the constructor method to make the queue and initialize its variables. We have to call the main method, create the main method so that all the functions, individual functions can be called in that. So this is how you create the main method in Java. Public static void main string args. Once this main method has been created by you, that is public static void main string args, then you have to in the real time you have to make use of the basically the constructor. So whichever is the constructor you have created, you have to make use of that. So q is the name you have given to that constructor. So q equal to new q. This is how you create a constructor. Q is the constructor name. Q was also the class name we have given. But then in our case, we have the constructor name as main. Yes, we have the constructor name as main. You can give any name. For simplifying it, I was saying you can use Q because we're dealing with Qs. But since we gave our name as we are making use of the online compiler and we have given the name as main, let us give main q. Q is the object. Q is the object of the main class, and here main new is the operator which you are using for initial instantiating basically, or creating instance of the class. Instance of the class is nothing but the object q here. So new main of the size you have to give. Let's say we can just say the size is 4 for now. That is, a queue is having 4 elements for now. Once that is done, we can say, for example, we have created the queue of the capacity as 4. Now we want to just print the initial queue we want to say. Then we can just print the initial queue by writing the statement initial queue. It can be, yes, initial queue. Then you have to use the display method basically to display all the elements of the queue. So we can use q dot display. Display was the function we have used for we have created for printing or printing all the queue elements. Now inserting the elements into the queue. How do you insert elements into the queue? You have to invoke the enqueue method. So q is the object you have created, right? So q dot enqueue. Q dot enqueue of 10. First element has been enqueued. I'll just write this command again and again. Enqueue, enqueue, enqueue. Since there should be 4 elements into the queue, and you can just give different values to them for each of the elements. Obviously, you can have duplicate elements as well, not an issue. But for now, let's give different values. So the queue is having 4 elements, 10, 20, 30, 40. And then now you want to print all the elements of the queue. So for printing all the elements of the queue, we can just make first this print method. So that q after enqueue operation, it is for your understanding. We can write q after the enqueue operation or the insert operation is done. Initially, we have used this method of uh, print over here to just print the initial queue, which was empty. But then after you have inserted, perform the enqueue operation, then we want to check what are the elements present in the queue. Then q.display is the method for displaying all the elements of the queue one by one. So in order to display all the elements of the one by one, you're making use of q.display operation. And then after q.display, you have to also, for example, say you want to insert the element in the queue. Again, you want to again insert an element in the queue, a new element in the queue after doing the display again. So let's say q.enqueue was the name of the insert operation, right? So q.enqueue of let's say give us a different value 90. You are enqueued the element into the queue. Now after enqueuing this element into the queue, again print all the elements of the queue. Q.display. So basically first in first out. So it will print the elements of the queue like this: 10, 20, 30, 40, 90. But when you are performing the operation of DQ, then whatever element is inserted first, that will be deleted. Unlike the queue, unlike the stack. So in stack, we have seen if we have done the removal or the deletion operation, 90 will be the answer. But in our case in the queue, 10 will be removed. Instead of 90, 10 will be removed because 10 was first inserted into the queue. So it follows FIFO principle. Please make a note of this principle which queue follows. It is called FIFO principle. First in, first out, which is followed by the queue. So 10 is inserted first into the queue, it will be removed first. So q.display. Now let's say you want to delete the element of the queue, right? You want to delete elements in the queue. Now let's say q.dq. DQ is the method for deleting. Now DQ does not need any argument. Like as we have seen, pop also does not need any providing any value. DQ also does not need any deletion operation, does not need any value to be given by the user. Let's say we want to delete 2 elements. So how many elements you want to delete? You have to call the operation DQ operation those many number of times. So suppose 2 elements you want to delete. So 10 and 20 you want to delete. The final answer will be 30, 40, 90 because the first 2 elements at the front end of the queue will be deleted. 10, 10, 20 will be deleted. Then let's say you want to now print the elements of the queue. So I'm just copy pasting this element. Copy pasting this function here, the statement system to print an queue after DQ operation, because now you have used the DQ method. So you can change it to DQ operation to check what are the elements of the queue now. So how do you print the elements of the queue? Queue dot display is the function we have created, right? The display method which will print the queue elements. So now that this is the, now we have made this main method, this is corresponding to the class. Yes, so we just need two braces here. Now let's see what this program will give us the answer as. Int array cannot be converted to int. So there is in the 10th statement. So as we see here in the 10th line, q equal to new int of capacity. So over here, front equal to rear equal to 0 is correct, because that should be how, okay, it's right. I've included int array again and then q again. Okay. So only once. See, this is how you have to initialize. So once you have declared the queue, this is how you have to do it. Just only once, because it was not a 2D array. It's only a 1D array you're creating. So that's it. So this is how we get the basically the answer. As you can see the output here, initial queue is empty. Why is queue empty? Because initially when we did not even insert any or perform any enqueue operation, queue is empty. That's why it's returning that. Now after we have enqueue, perform the enqueue operation. As you can see here, this is the constructor. Please make a note of this program. It will be helpful for you to understand the enqueue, dequeue and the display method operations in queue. So as you can see here in the, this is the main method where we are calling individual functions of the queue. So enqueue method, edge cases, queue when queue is full, when queue is empty. Queue is full when capacity equals to rear. Queue is empty when front equal to rear. Front and rear is when they are zero itself, they initialize. That is where queue is empty. No element is inserted into the queue. But then when will queue be full? Queue data structure will become full when capacity is reached to rear, the end of the queue basically. So queue is empty, but after performing the enqueue operation, 10, 30, these are the elements 10, 20, 30, 40 we have inserted into the queue. So after inserting these elements into the queue, like you can see here, we have inserted these elements into the queue. Enqueue by performing enqueue operation 10, 20, 30, 40 in the FIFO. So 10, these are the elements after the queue, in the queue after the enqueue operation. So it is printing queue is full. Why is queue is full? Because the when we have given the capacity of the queue over here on making this in the main method, we have created an object of queue class, which is queue, and given the capacity to it as 4. So when the queue has a size of the capacity as 4, it says that already 4 elements are inserted into the queue. No more enqueue or insertion operation can be done because queue is full. That is why queue is full is the statement which is printed here. Then 10, 20, 30, 40 is again printed. And then queue after dequeue operation. Now performing the dequeue operation. As queue is full, even when you try to insert this 90 over here, we have performed enqueue operation by giving 90. It is not going to insert 90 here because already the size of the queue is 4 and it is reached to full. So there is a queue overflow condition here because no more elements can be enqueued or inserted into the queue already, because 4 elements are present into the queue. Unless we delete an element or remove an element from the queue, you cannot add or insert new elements into the queue. So this is why it is returned queue is full and just giving us the previous queue itself without enqueuing 90. So display method will return this queue dot display is returning us 10, 20, 30, 40 as the elements of the queue. Now performing these two dequeue operations. As I've told, the pop operation in stat, when you have done pop operation in 10, 20, 30, 40, 30 and 40 will get removed. But in queue, when you are performing the deletion or the dequeue operation, 10 and 20 will be removed instead of 30 and 40. As you might be have understood now why 10 and 20 will be removed, because it's following the FIFO principle, first in first out. So 30 and 40 is queue after the dequeue operation. 30 and 40 are returned as the output of the display method. I hope I have made all the concepts very clear to you by line explaining you hands on what each operation is doing and why the output is coming in such a way. So these are the basic operations you have to be aware of while understanding the queue data structures in Java. You can obviously perform these operations of queue as well as stacks on all these operations in other programming languages as well. So now that you have understood this, let us understand what is the linked list in Java. So linked list is basically, we can say that it uses a doubly linked list to store the elements. The Java linked list class especially, it uses a DLL concept, doubly linked list, right? But then the important points which you have to, core points before starting any queue concept, you have to understand, like I was explaining you in the first part of the video, that queue has elements which are connected to each other by pointers. Okay, they are connected by pointers. So pointers is nothing but to link the elements of the queue. So the Java linked list class can contain duplicate elements also. It need not be the case that it cannot have any duplicacy. It can contain duplicate elements also in Java. So you can basically in queue in the linked list method. You can use the constructor in Java as well, like how I have given a constructor over here for the queue, like main constructor, and then initialize the member variables front, rear, capacity in the queue. For you make use of the linked list instead of main. You can call linked list as a constructor, and then it is used to construct an empty list. So basically, whenever you want to create an empty data structure, you use constructors by giving it some initial value. Similarly, the linked list constructor in Java is something you can use for creating an empty list in Java. So now that you have understood the core concepts of basically the linear data structures, let us hands-on understand the linked list also. By giving us, I would like to give you a simple program first so that you would understand how basically a linked list can be created in the first place. So firstly, you have imported the Java, you have imported the util package here, then public class main. This is the name of the public class here. Then let's create the public static void main method, the main method of your linked list. Public static void main string args. So once this is done, public static void main string args, this is how you have to create the linked list. Name of the data structure, linked list, then the type. For example, let's say why always integer. Let's give a different data type like string. So when you're giving it a string data type, al equal to new linked list. See, anything, be it any array, linked list, or stack or queue in Java, you have to, the basic concept is like, for an integer, how do you do it? Int a array equal to new int, and then specify the size, something 12. So it means this a array is the name of the array, has size of 12. Similarly, this linked list is created, and for now we have not given this a size, so for now it is an empty linked list. Okay, this is an empty linked list. But in our case, in array, we have created given it a size itself here. So this is how you have to understand that these kind of data structures have a particular fixed size. Their size is not dynamic in nature, but array list has dynamic. It's a dynamic data type data structure because its size can be varied. The size need not be fixed length. So once we have created an empty list like this, which is of the string data type, then you can add elements into this linked list. Add, now comes the method which will differentiate your linked list, take stack and queue. Like you have seen for stack, for insertion operation we have the push, then for queue you have enqueue, for linked list you have add. Add is the basically the function you will be using. Add is the built-in function which is for inserting elements into the linked list. So when you want to insert elements into the linked list, for now let's say I'm just want to insert some letters. So let's keep inserting elements like this. So once you have inserted all the elements into the queue, like A, B, C, and let's add one more element into the queue, into the linked list, like al dot add. Now these four elements A, B, C, D have been added to the linked list. Now in order to traverse and print all the elements A, B, C, D one by one from the linked list, you have to create an iterator. Iterator in Java is basically a class in Java. It can be of any type, but since the type of the linked list we have is string, that is why you're creating iterator also of the same type, data type as the data. So the data structure over here you are using is of the string type. So you have to create iterator of string and name it something like ITR maybe. So let's say ITR al.itr. In this way, you can create an you basically invoke the iterator method, the iterator class. So when you're doing that, al.iterator is the way in which you have to assign it to the itr variable. Once that you have done this, you can make maybe a while loop or a for loop just to traverse. Now see, you have to understand how to traverse elements in any data structure. Left to right, how do you do it? You have to use some variable, a counter variable which keeps on updating its value or keep, so that counter variable over here is itr. In our case, it's the iterator. Now, we can check if this iterator has next or not. Has next is the function here, which will check if there is some element present as next or not. So if the iterator, which is used for traversing elements in a data structure like a linked list, it will check if a particular element in the linked list is having its succeeding element or not in the linked list. If it does not have any succeeding element, it will just come out of this while loop. If it has a succeeding element, it will keep on iterating. That is the role of this has next function. You have to you have to be aware of these kind of functions. So you can make a note of these kind of functions and why they are used for. This will come handy, especially while dealing with hash maps, hash sets, and various other different types of data structures. So itr.next. Now next is the built-in method you're using. So this is a key difference between next and has next. So basically both of them perform the same kind of operation itself, but next is for moving to the next. So whenever you want to keep on updating, like you do rare plus plus in the basically in the queue, where you have seen that in order to move on to the next variable, you have simply incremented your counter as rare plus plus, right? But then in your linked list, whenever you want to move to the next element, you do itr.next, that is the object dot next. But then in order to check if the particular element of a data structure linked list has any succeeding elements or not, for that to check is used has next. You're going to use this function has next. So has next function, basically it is a boolean data type, because it's going to return a true or a false. It's basically to check if the next element is present or not. But dot next method is used for moving to the next element in the data structure. While is closed, then main method is also closed, class is closed. We can remove this extra brace here. Let us check what will be the output of our code. Iterator variable al of type linked list, so cannot find symbol al, and that is in 10th line. Iterator itr is equal to al dot iterator. Yes, I over here should be smaller letter. This is the standard format in Java that you have to follow, that iterators, some data type, and then the name of the variable or the object you're creating. Then you're invoking it with the help of the data structure you have created. In our case, linked list. If you are making use of a stack or an array, then you can use that dot iterate or dot the name of the method. So yes, as we see here, A, B, C, D are the elements which are present in the linked list. Is it correct? Yes, we have inserted the elements A, B, C, D, and these are in a linked list connected to each other by pointers. You have to understand the concept of pointers, especially in C, C++, to give a visual demonstration of what exactly I'm saying. It's something like this. This is in fact in stacks, but in linked list also the elements, they are connected to each other by pointers. So you have the head element, then each of the elements, which the two components of any linked list will contain the data of the linked list, that is a value present in the data of the linked list and the element, and then the reference to the next element. So if there is a next element over here in the linked list, the reference address of the next element will be stored over here in the next component of the element of your linked list. So this is how they're connected to each other. Now that you have understood, we have inserted, you're making use of the add operation here. Add is the function. Okay, add is the inbuilt linked list function for adding any element or inserting any element into your linked list. And for traversing your elements into the linked list, you're making use of this iterator. Has next is for checking whether the next element is present in the linked list or not. And dot next is for updating or moving on into the next element. element of the linked list. Let me give you a few applications, real life applications where linked list will come handy to you. Especially you will hear of a problem called hare and tortoise problem, or basically you can say checking whether a linked list has a cycle or not. So you will see that there are various elements connected to each other. But how do you actually determine, or how do you check whether there is a cycle which is existing in the linked list or not? So check the cycle as in it says that whether one element is connected to the other element, and the other element in fact is again forming a loop, which there's a loop basically, and is again forming a connection to the first element itself. So that is a concept of cycle or loop. So to check whether there is exists a loop in a data structure in a linked list, you use linked list. And linked list in fact will come very handy to you, especially there will be many data structure problems when you do your hands-on practice. There will linked list is a core concept, and there will be concepts like merging two linked lists, or removing a node present at one particular index of the linked list, adding a particular element into the linked list, all those concepts. So basic operations and functions like add, insert, enqueue, dequeue will be everywhere that you have to be very much aware of. And then you can apply those logics and into the functions itself, into your solving of the problems itself. So that was all about linked list. I hope I have given you a brief about how exactly you can insert elements into the linked list. Let us now, I would really like to give you an example of in Java, how to reverse elements of linked list. So basically, if you have this A, B, C, D, how exactly can you reverse these elements into the linked list? That is, D, C, B, A can be returned instead of A, B, C, D. Let us have a look to that. So iterator, this is okay. So instead of, iterator over here is iterating or traversing the elements of the linked list from A, B, C, D order. But you want to do it in the descending order, right? You want to traverse them D, C, B, A, or in the backwards order. For doing that, let me remove this statement. This statement only has to be removed. See, this is one of the applications of linked list. Whenever you want to reverse elements, a list of elements, then this is how you have to do. Iterator I, let's say any variable I, and the name of your linked list is AL. So AL dot descending, because that is how you want to reverse the elements into the linked list, right? So reversing elements into the linked list is done by making use of descending iterator. Descending iterator is the inbuilt Java function method. So you're making use of that by invoking on this AL, which is the linked list object of yours. So AL dot descending iterator. Descending iterator is the inbuilt linked list method or a function. Then the while loop is as it is. Instead of itr, you have I as the name of the iterator object. I dot has next. Has next is the same. It will just check whether next element is present or not. If it is present, then print the next element, I dot next. That's it. So the only difference you have to do that instead of printing A, B, C, D as it is, you make use of this descending iterator, and as expected, you can see the output as DCBA, which is going to reverse all your elements present in the linked list and print them in the reverse order. Similarly, instead of inserting string, you can insert numbers also and check for yourself how the output will be. It will work the similar way for the numbers as well. So I hope I have made this concept clear to you about how you can basically insert elements into the linked list and also reverse elements from the linked list. Now I want to give you a last example to help you understand exactly how linked list is working in Java by giving you an example of a book. So, a book, I'll also be making use of object-oriented programming here, because Java is object-oriented programming language, so that it has everything in the form of classes and objects. See, as you can see here, this is a class. Linked list, in fact, is a class. It's a data structure, but it's a class which is a part of which extends the collections interface in Java. And interface is a different concept in OOPS, which is again a class type of class. So you can see collections is also a class, and it is a linked list is extending the collections class in Java. Collections framework in Java. And then we are making use of I've also explained you in the codes while demonstrating how constructors are especially used for initializing the member variables of a class. They're having the same names of the class itself, but are used to give initial value to the variables, or give to the members of your class. What are methods? I've explained you how to create new objects, making use of this new operator, which is used for instantiating your objects. Now I would like to give you a real life, some application which is for a book. So you know that a book will have different characteristics. It will have the name as its attribute. What are the attributes basically? Attributes are the features of a class. So if I say book is a class, it has different features, right? Like author, publisher, the quantity, the different, basically the name of the book, title. These are different attributes of your book class. Now let us see how we can make use of a linked list. Basically how we can make use of this concept of linked list in order to add different books to a linked list. So if there is a library will be having a list of books, right? So let's create for now a small list having just 4 or 5 books in it as objects. There's the elements of the list, and let us check how we can traverse the list and print the names of the books one by one. As I've shown it to you with the just ABCD, I would like to show it with you by making use of the books. So import Java is the first, this is common. Then public class main. Okay. Then after public class main, let me give you one int ID. This is one like ID. Book ID is the attribute. One of the book will have is assume that every book, like we all have roll numbers, right? So or employee IDs. So similarly, book will have some attribute called ID. Then string, name, author. These are the attributes of the book. Author, publisher. These are the different attributes of your book. Then you will create a constructor. Now constructor will have the same name as the class. So let us create the constructor. Public main int ID author quantity int ID, and then yes, the data types as well you have to provide. So string, author, publisher, let's say it's string, and quantity is int. Then after doing this, now inside this constructor, how do you exactly initialize the variables, the member variables? You do it by making use of the this keyword. This is to reference an object to itself. So whenever this is an object ID, you're referencing and assigning it to the value ID itself. Okay. This dot name equal to name. Basically this is the keyword to reference the object to itself, the instance of the class to itself. So this dot author equal to author. What was the other attribute? Publisher. See, this is like a common attributes any book library will have, any book will have. So this dot quantity equal to quantity. After we have done this, now let's, okay, this is inside this class. Now once this is done, let us say we can maybe make instead of like making a public class, let's make it a class only. Instead of making it public, let's name it as book only, because these are the features and the attributes of book. We cannot make it attributes of anything else. So we want to make use of a book class, and let's make another class. This is a book class, but there should be another class like your main class in which your main method is there. So your main method will be in the public class main. So let's create a different, give a different name to it, like public class main. Inside public class main, there should be public static void main as the function. This is the function. And now in this function, you're creating a list of books, right? So instead of the string as the class, you're giving the type of your linked list to be book. Let us name it as list itself. For easy understanding, let us name it as list. So linked list book list is equal to new linked list, and the type of here should be book. It's not a string data type, it's a book data type, because book is a class and it has different, then we'll be creating objects of the class, and the here this also has to be changed because it's a constructor. Constructor has the same name as the class. It's a method which has the same name as the class and is used for initializing the attributes of your class. Attributes of your class here are ID, string name, string author, publisher, and int quantity. So once you have created of the book type, now you can create books basically. Now, how do you create books? In order for you to create books, you have to make use of the to create books, you have to instantiate objects. That is, create different objects of your book class. Now, book is a class. Book B1 equal to new book. By making use of this new command, new operator, you can create the objects. So let us say something like data is the name of the book, data book. The name, the author of the book, let's just give any name to the author in the order of whatever we have passed. So author, publisher, publisher also, let's give any name to the publisher. The next argument is quantity. Now quantity is a integer, so it need not be enclosed in string. It has to be not be enclosed in string. Once we have given the quantity as 6 or some value, we can similarly create another object of the class book, which will be B2, because no two objects can be same. So B2, and just give a different value. Data book, and maybe some OS. Galviner, I'm just changing slightly for just giving a different value. William, and give the quantity as some different number, like some maybe 5. So for now, let's assume there are two books itself. Two books in a list of books. Like two objects basically. Two objects are created, B1 and B2 of the class book, of type book. Now you are adding the elements into your list. Your list was this name, list. How do you add elements into your list? By making use of the add method. So list dot add of B1. Then similarly list dot add of B2. You have added both the books, that is objects of class book, to this list object. So once you have added them, now to traverse your list and to print the values or print the all the books present in your list, you can do this by making use of the book class book, and then the basically iterable and iterator concept, where you're traversing or iterating through each and every element present in your linked list. So your linked list consists of just B1 and B2. You are iterating. Is the type over here is not int string. It is the type is book type, because we have created a class book. So the type is not string or integer of the object, but the type of the iterator is book. So book B, and then you're iterating over your list. So you have to write book B over your list. Now you can print all your books one by one, all the books present in the list one by one by just printing the statement. So how do you do that? B.id. You have to make use of B.id, because B over here is the basically the object you are using of type book class. So you have to invoke each and every attribute by calling it this way, B.id. For example, okay, B.id plus, let's give a space as such, plus B.name plus, so that one by one or each attributes of the book can be, or book object can be printed. So B.author, B.publisher, and then finally B.quantity. Quantity. Once that you do this, then you come out of this loop, which is for loop. Then, okay, this is the for loop. Next, this is for the main method. This is for the class, and this is extra. So this can be removed. Now let us see what will be the output of our function, of our program. Cannot find symbol. This dot quantity equal to quantity. Quantity is present here in the 11th line. So in the 11th line we have this dot quantity equal to quantity. Okay. So since we have like initially I have not given quantity, int id is given, but int quantity has not been declared. So quantity variable has to be declared because it's being used. Yes. As expected, you will see that names that is traversing your list of books objects. You will see the books, the attributes of the books one by one will be displayed. So the first book attribute when you're traversing in the list, the first object of your list is B1, which has these attributes 101 data book Galvin Wiley 6. This will be in your first line. After you have traversed the object or the element, then the next object will be considered. The next object B2 is taken, and the attributes, that is 102 OS and all the attributes of your B2 object of the book, that is B2 is the book object, that will be generated here. So these two are the output you get, the lines of the output. I hope I have made the concept of linked list clear to you to perform basic operations, how do I iterate, and also helped you understand with the help of object-oriented programming language as such. So now that you have a fair understanding of linear data structures, let's begin our understanding of non-linear data structures. So non-linear data structures, a tree. Tree is the most common non-linear data structure. Now, tree is basically defined as a finite set of one or more nodes. The elements of a tree are called as nodes. You have to understand this. And in a tree, there will be a root and a subtree. So this is a tree, and if each there will be levels of the tree. Like zeroth level is the start. Like in any array or linked list in the linear data structure we have seen, you have index values. So it starts from 0. Over here, you start the level from 0 and then go to the end level. So you move from top to bottom here. The starting or the first node of the tree is called as the root of the tree, and the last nodes of the tree or the elements of the tree without any further nodes, basically without any further elements, are called as the leaf values. So these are the leaves of the tree basically, and this is the root of the tree. So leaf, so you have to understand this as a basically a family hierarchy, because it's a hierarchical data structure. It's a non-linear data structure, and tree is a hierarchy, and application of that is a file data structure. So this is like your ancestor. These are your descendants. So B, F, this is a descendant of A. A is the parent of B, C, D, E. And B is the parent of F, G, H. F, G, H are siblings of each other because they are at the same level. You can understand this, very much related to the family tree itself. And these, the last one, L over here, is the leaf node. F, G, H, I, J, and L, these are the leaf nodes of the tree. Node is the element of the tree. And F, G, H, I, J, L are the leaf nodes of the tree because they don't have any further children. So the nodes of the tree which do not have any further children are called as the leaf nodes. Now that you have to understand the concepts of connectedness, absence of closed loops in the tree, basic terminologies like siblings, as I've already explained in the tree by making use, what are ancestors? Ancestors are nothing but like the you can say F, the ancestor of F is B and A. So whichever node will come before or preceding your node in the tree, that is called as an ancestor. Then you have to understand the concept of leaf nodes, which are the nodes or the terminal nodes of the tree which do not have any further children. Then the degree of the tree, height or depth of a tree, and forest. So as I've already explained, parent is the immediate predecessor of a node. You can make a note of all these terminologies as this will come handy to you. Please take time to take note of all this. As I've explained to you pictorially, root is specially designated node which has no parent. The top of the tree, the topmost node over here in the case A, is the root of the tree, the starting. Child, the immediate successor of a node. And each node of your tree stores the actual data and links to other nodes. Leaf is the node without any child. Level represents the hierarchy. So subtree of a node is a tree whose root is a child of that node. Something like we can say B is a subtree. B, F, G, H, because it's a part of this entire tree. So height of the tree is the number of nodes in the longest path to leaf from that node, whereas depth of a tree is number of nodes in the path from root to that node. So leaf to that node is height, and the number of nodes or the length of the tree basically from the root to that node is the depth of the tree. So when I say the depth of the tree over here, the degree of the tree is 4 because over here degree is basically the we can say the degree of the tree will be the number of children for the node in the simple term. So the number of children, the degree or the maximum degree of a over here, the number of children it can have is 4. So like B, C, D, E are the children of A, the child nodes of A. So the degree of the tree node A is 4. Height of the tree is 4 because it's the number of nodes starting from the leaf node to the root. So the longest path to a leaf from that node is called the height of the node. So it's basically we can say maximum level plus 1. So height of the node over here is 4. The maximum level if you see of the tree, the levels start from 0. So 0, 1, 2, 3. It's 3 over here. So 3 plus 1, maximum level plus 1 will give us the height of the tree, which is 4. So these are the just the pictorial representation, a theoretical concept for you to understand. Now let us understand what exactly are the operations which can be performed in trees and what are the different types of trees. Now one important type of tree is the binary tree. You have understood what is a tree. Now binary tree is defined as a finite set of elements called nodes such that basically binary tree is called empty if it is, or empty tree is also called as a null tree or an empty tree. And a binary tree on the other hand is has the characteristics of all nodes having at most 2 branches, that is all nodes having a degree of at most 2, that is the number of children of the node should be 2, at most 2. It cannot have more than 2. It should have 2 or less than 2. It can either have 0 children, or it can have 1 child, or it can have 2 child nodes. So every node should have at most 2 children. That is, the degree of every node present in the binary tree should be at most 2. That such type of trees are called as binary trees in data structures and algorithms. So binary tree can be empty, as I said. It can either have 0 children, or it can just have 1 child node, or has 2 disjoint binary trees termed as left subtree and right subtree. So given this example, I have told you what are subtrees. The left subtree will be this part, BDE. The right subtree will be CFG with C as the parent node. So once this is done, you have understood what is binary node. I would like to give you an example of how different binary nodes can be represented. Binary trees can be represented by making use of tree again is a non-linear data structure, but definitely you can express the tree by making use or represent the tree by making use of linear data structures. So you can make use of arrays or other data structures as well to represent tree. You can make use of linked list, like linked representation of a data structure, linked list, to represent a tree which has left child, right child, and the middle data. This is how you can do. So these are the different ways. Now you have to understand 3 different orders while traversing a tree. Traversal is basically, as I was talking about in the previous data structures, like linear data structures, traversing or traversal concept in data structures is nothing but processing. Processing your element or processing each and every node or element of a particular data structure is called as traversal. In binary tree, you have 3 different types of traversals, which are pre-order traversal, in-order traversal, and post-order traversal. Pre-order traversal is in the form of left, root, right. So, root, left, right. So, first you process the root R. First, the root of the tree should be processed, then go to the left part, then go to the right part. Please make a note of this. That is in the short form NLR. N is the root node. Okay, N is the root node. So first the top or the root node of the tree, followed by the left subtree, then the right subtree. NLR or root left right is the traversal order. Like you have different orders of traversal, right? You can traverse a tree from different ways. So basically, pre-order means, as the name indicates, pre means the root will be first processed. That is why it's called pre-order. So first process, whereas in post order, as the word says, post means at the end. So root will be processed at the end. So first left, right, then root. That's it. It should be LRN in the post order. In order, it is in the ascending order. So in the ascending order, nothing, we can just say left, root, and then the right. The root should be in between. Left should be processed first because left is less than root value. Root value is less than right value. Right value is the extreme value. That will be processed at the end in the in order. This is for the pre-order. Root, left, right. In order, as I've told, it is left, root, right. N stands for root. So left, root, right is the order for in order traversal. For the post order traversal, you have left, right, root. I would like to give you with the help of a pictorial representation here to make it easier for you to understand the different types of traversals in a tree. So if you see the pre-order traversal, this is a tree having the root node as 1. The child nodes over here as 3 and 7 of 1. And similarly, you have the left subtree and the right subtree. Now, the pre-order traversal over here will be visiting the root first, as the name says pre. The root of the entire tree is 1. Then you move to the left side, then you move to the right side. So when I say move to the left side, you go to 3 because it's the root. Then you go to 5 over here because it is the left side. Then you go to the left side and then to the right side. At the end, so basically, as you can see, rightmost part of the tree, subtree, should be evaluated at the end itself. So similarly, you can just say all the rightmost nodes can be evaluated afterwards only, can be processed or traversed later. That is why you can put them at the end. Systematically, when you're seeing in the right subtree, you're moving left, moving to the root node, which is 7, then moving to the left, which is 8, then moving to the right, which is 9. There is no left subtree here, so just go to 10, then the left subtree 11, and then 12. 12 is the last node of the element to be processed in the entire tree. This is the pre-order traversal. In-order traversal is in the order left, root, right. So left over here, go to the left part of the subtree, which is 4. The leftmost side will be processed first. Root will always be in the middle, followed by right will be the end. This is the order. Please make a note of it. Post order, on the other hand, the post means the last. So post order means the first, basically the last, the root of the tree will be processed at the end. So root of the tree, which is it has to be processed at the end, which is 1 over here. So it is you simply you can just write 1 at the end here because that is processed at the end. So the format is this way. Post order means it is left, root, left, right, and then root. So please make a note of this. Similarly, you can just practice on other examples as such to understand clearly what are the different types of traversals, like in order traversal, which can be done with stacks. So basically, the concept of non-linear data structures, as I told, they can be definitely be solved by using different combinations of data structures. Like you can use in the pre-order, you can use stack, you can use stacks concept over here to traverse the in order way, or we can also use queue data structure to traverse like there are different applications of such, like infix, postfix, to convert one to another. So all this can be done by making use of the linear data structures as well. So now that you have understood the basic concept of trees, I would like to also give you a gist about what we have studied so far. We have basically learned about the linear data structures in depth, the non-linear data structures in depth, and then in the upcoming video, now the last topic which is left to be dealt with is the graphs data structures. So graph data structure is also a part of the non-linear data structure, and we will be looking into the graphs data structure in the last video of ours, which is upcoming, which will be the part 3 of your data structures concept. And I would like to give you the types of just about the types of the graphs which are there in data structures and algorithms, and also which kind of algorithms are used for traversing the graphs. Like as we have seen in trees concept, you have pre-order, in-order, and post-order traversals. Similarly, in graph concept, you will have DFS and the BFS concept, which is depth first search and breadth first search for graphs. And over there also, you will see how DFS will be used and linked with stack, which is a linear data structure, and graph, which graph is a non-linear data structure. But the BFS of the graph, which is breadth first search, is linked with and makes use of the queue data structure. So you will see that DFS uses stats and DFS uses queues. In the upcoming video, we'll be seeing the different types of graphs, the BFS and the DFS algorithms, and we'll also be seeing few applications of where graphs can be used in solving problems. I hope I have made the concepts of coding clear to you and you were able to follow. Hope you like and have a good day. Thank you.